All right, guys. Like I said, our next lesson, what we're going to be doing is we're dealing with slopes. Okay, we're dealing with taking slopes and being able to write equations. So we talked our last lesson rather about slopes, and now the question is, how can we take what we know about slopes and be able to write a full y equals mx plus b standard form of a linear equation? You guys learned this in Algebra 1. How can we, from different pieces of information, write a full equation? So what I'm going to do is I'm going to walk through several examples of this. And if you missed our day of notes, I would say just what I had us do in class was just follow along with each of these types of examples and then get started on our own. Okay? So here's the information I'm giving you. I'm giving you a point, and obviously I'm giving you the slope, otherwise known as m, from that y equals mx plus b. So what I would suggest is fill in what you know. All right, so guess what this equation is going to look like? Y equals negative 4/3 x plus something, plus some constant value, otherwise known as the y-intercept, some constant value here at the end. Well, how do I figure it out? Here's what I always try to remind people. You have three variables here. 1, 2, 3. It's pretty difficult to solve for three variables. Luckily, I have information here that I can use to replace two of those variables, x and y. 0 equals negative 4/3 times negative 3 plus b. So 0 equals, this is going to be positive 4. Negative 4 times negative 3 is positive 12 divided by 3. So 4 plus b. Then I can subtract 4 from both sides. B equals negative 4. Now I have both pieces. I have the b value, and I was already given the m value. So my final answer, why don't I change my color for the final answer, is y equals negative 4/3 x minus 4. That equation right there, if I were to graph it, would obviously have this as a slope, and it would contain this point. And therefore, that's my final answer. That's the equation. I'm not asking you to graph it. Just tell me what equation would match these constraints. All right, next possibility. I don't give you the slope. I just jump right in and say there's 2 points. All right, so if you imagine like what this looks like, I'm saying there's a coordinate plane, and there's these points, 4, -1, and 0, 2. And obviously there's got to be some line that goes through those points. What's its equation? Step 1, I need the slope. And that's the change in y over the change in x. And that, in this case, right, let's see, x1, y1, x2, y2. 2 minus -1 over 0 minus 4. 3 over -4, but proper math grammar says I should write it like this, -3 over 4. Okay, great. So now I have this. Step 2 is that I have y equals -3 over 4x plus some y-intercept. Now maybe you're super clever and you go, well, Mr. Card, isn't this the y-intercept right here, 0, 2? Because aren't all y-intercepts containing a 0 as the input and then a b as the output? So isn't that what it's got to be? And I would say, yes, that's true. And if you're clever enough to just figure that out, then you're done. You would just stick a 2 there. But let's say you don't pick up on that, or let's say it's a problem that doesn't give you the y-intercept as one of the 2 points. We almost got lucky here. Right? Well, in that case, you're still fine because you can pick any of these points, either one. Plug them in here just like we did in the last problem. You have an x and a y. So if I have 3 variables, y, x, and b, and I'm only looking to solve one of them, I should find a way to replace these other 2 variables. So why don't I do that? Negative 1 equals negative 3 over 4 times 4 plus b. All right, well, when I do that, the 4's are going to cancel. So negative 1 equals negative 3 plus b. Add 3 to both sides. B equals 2. All right. So y equals negative 3 over 4x plus 2. That equation would be the equation for this line. So now we get to start making them a little more complicated. What I mean by that is, what if I give you a point and I say, yeah, I want the equation for the line that goes through that point, but the constraint is I also want it to be parallel to some other line. So imagine that kind of like this. You got this point, 5, negative 2, right out here. And then you got this line, negative 7/5 x plus 4. So you got this line that goes like this. Negative slope, positive y-intercept. So probably looks something like that. It's just a sketch to give me an idea of what's happening. What I'm asking you for is, there's got to be a line that goes through this point and it's parallel to the other line, but what is it? Well, luckily, like we talked about yesterday, all parallel lines have the exact same slope to each other. And not that all parallel lines have the same slope, but anything that's parallel to this line is going to have the same slope. So my step one is that I already know that this dashed line has an equation that will at least look like this. Y equals negative 7/5 x plus some unknown y-intercept, right? Like this clearly has a different y-intercept than this one does. They're different lines. And I don't know what it is, but I'll figure it out the same process I've been using. Sub in these variables. Negative 2 equals negative 7 over 5 x plus b. Oh, I forgot to plug in the x. So times 5 plus b. Oh, look at that. Negative 7 times 5 is negative 35, divided by 5 is negative 7, so the 5's cancel. Negative 2 equals negative 7 plus b. So 5 equals b. So my final answer, y equals negative 7/5 x plus 5. We have one more to go. You guys might be able to guess where this is going. Okay. What I would deem probably the most difficult ones, which is perpendicular. Because we cannot get too ahead of ourselves and say, oh, they must have the same slope, because what do we know about perpendicular lines? They don't. They have what's called opposite reciprocal slope. So here's the situation I want you to imagine. Negative 2, negative 3, there's this point. Negative 2, negative 3. And then here's this negative line with a negative y-intercept, so it probably looks something like this. There's gotta be, there must exist that dashed line. The question is, what's the equation for that dashed line that runs through perpendicular to the other line and goes through this point? Well, step one would be, I need to take this slope and convert it. Take its opposite reciprocal, which would be, used to be a negative, now it'll be a positive, and flip it, 7 over 2. So I know y equals 7 over 2x plus b, and I'll take this point and replace my x and y. Negative 3 equals 7 over 2 times negative 2 plus b. So that's going to be negative 14 divided by 2, that's negative 7. So negative 3 equals negative 7 plus b. Add 7 to both sides. B equals 4. So my equation is y equals 7 over 2x plus 4. And there you go, you guys. We've walked through an example of each one of these types of problems. I would encourage you to please come back to this video anytime you're struggling, right? Because you can just fast forward right to the part of the video where I'm doing the type of problem that you have to do. And hopefully it'll give you a good example. All right, and that is a wrap. We're almost done with chapter 3, but we'll have, I think, probably 1 or 2 more videos for this chapter.